All right, so what we're going to be looking at in section 8.5 is something called variation, and it's basically looking at different variables, different quantities, and showing how one of them is going to affect the other. You know, as one variable increases, what happens to the other variable? As one variable decreases, how does that affect the other variables? So direct variation is the first one that we're going to be working with, and direct variation looks like this. Varies directly, we say y varies directly as x. If y is equal to k times x for some constant k. Okay, so we don't know what this constant k is. We will eventually find out what this constant k is, but we call k the constant of variation. Okay, so the constant of variation is k. And so what direct variation means is that as one of the quantities goes up, the other quantity goes down. Okay, so that could be something like your wages compared to your hours. As your number of hours goes up, your wages go up. As your number of hours go down, your wages would go down. So that's what it means for one of them to directly affect the other one. All right, so if, like it says here, if we know y varies directly with x, if we know one set of values, we can use a proportion to set up the other one. So say you know, for instance, that if you work 10 hours that week, you're going to make $90. You'd be able to figure out how much you made if you worked 15 hours. So that's the proportion that we're going to work to set up. So we start with this relationship. We say y1 is equal to k times x1. So that's one set of values. And then you would know y2 is equal to k times x2. So we've got those two different relationships. So what we're going to do with both of these is solve for k. Okay, so we would know that y1 divided by x1 is equal to k. So we could get k by itself here by just dividing by x1. We could do the same thing over here by dividing by x2. Okay, so our final touch is now that we're both equal to k, it's kind of like a substitution idea. If these expressions are both equal to k, then they must be equal to each other. Okay, so this is the formula that we use for direct variation. Okay, so that is our direct variation formula. And so we use this in order to solve these direct variation problems like this. So we say if y varies directly as x, and so as soon as we see this expression right here, we know we're using this formula. So we know one set of points. So this is like our y1, this is like our x1, and then it says find y, so we want to find y2 when x equals 3. So that's our x2. So we're going to set these four numbers into this formula. So y1 over x1 becomes negative 15 over 5. And we know that's equal to, we don't know y2, so that's our variable, over x2, which is 3. So this is just a proportion that we're going to end up solving. So we simplify it up as much as we can. So like the left-hand side, for instance, reduces down to negative 3. And then in order to get y2 by itself, what we do is multiply both sides by 3. Okay, so these 3's would cancel, and then as it turns out, y2 is equal to negative 9. So that's how we solve those direct variation problems. Joint variation is a similar sort of idea. Joint variation occurs when one quantity varies directly with multiple other quantities. Okay, so we say that y varies jointly, we could say as x and z, and you might have more. We're just going to do an example where we have 2. And then it says if we can find some value of k, like this. Okay, so I'm going to write, for example, in an area function, hopefully you guys recognize this as a triangle, we would say area varies jointly as base and height, which means as the base goes up, the area goes up. As the height goes up, the area goes up. So let me give you guys an example for direct variation, because I just realized I did not. Let's say that your wages are equal to $10 times how many hours you work. So that would be a direct variation example. Let's look back at joint real quick. Okay, so we're going to do the same sort of setup that we did in order to set up our formula. So our formula works like this. Let's say we have our first set of data. So we're going to use this formula for our first set of pairs. So k stays the same because that's not a variable. We just don't know what k is yet. So our first set of points, so it says if we have x, z, and one set of values, we can use a proportion to find the other set. So we also can set up a second set of data. This is really similar to what we did up above. We just have a second set of values. So like that. And then what we're going to do, just like we did up above, is we're going to solve for k. So divide both sides by the x and the z, and we'll get k by itself. Do the same thing over here. So now exact same idea as we did with direct variation. Since both of these expressions are equal to k, we can set them equal to each other. So this is the formula that you use anytime that you read a statement like this. Suppose y varies jointly as x and z, you would automatically set up this formula. And so now we've got all of these values to plug in. So it says find y. When they tell you to find something, that's that second set of values that they want. When x equals 10 and z equals 5, if, and then when they give you a statement, those are all your ones, your y1, your x1, your z1. So that's y1, that's z1, and that's x1. Habit you might want to get into is putting that little horizontal cross through the z just so you don't confuse them with your 2's. So we've got all these values. We're going to plug them into this formula right here. So y1 is 12. And then x1 is 3 times z1, which is 8, equals y2, which we don't know, over x2, which is 10, times z2, which is 5. Okay, so we're just setting up that proportion. We're going to simplify it down. So I've got 12 over, this multiplies out to 24, equals y2 over, this multiplies out to 50. So I'm going to reduce it down. So 12 over 24 reduces down to 1/2, equals y2 over 50. And then to get that y2 by itself, I'm going to multiply both sides by 50. Okay, so these 50s would cancel, and then this would reduce down to 25. Okay, so that is your answer. When it says find y, we found y, and that would be our final answer. Okay, next topic that we're going to look at is inverse variation. So with direct and with joint, as one variable went up, the main variable went up. That's how direct variation works. Joint is just kind of like an expanded version of direct variation. The way that inverse variation works is the exact opposite. If one variable goes up, the other variable goes down. And that's what that inverse idea means. So inverse variation, we would say that y varies inversely as x if you can set up an equation like this. Okay, so again, the basic idea with inverse is that as one quantity goes up, the other quantity goes down. So an example that I want to give you is how time and speed relate to each other. So the amount of time that you spend doing something would be inversely proportional to the speed. So the faster you go, the less time it will take. The slower you go, the more time it will take. So let's say, for instance, that you are driving 40 miles per hour. Okay, so the time that you have to go, actually, let's say you have to go 40 miles. If you have to go 40 miles, and then you divide it by your speed. So the time that it takes you will be 40 miles divided by the speed that you're taking. So if you're going 40 miles per hour, 40 divided by 40 would reduce down to 1. But if you're only going 20 miles per hour, then 40 divided by 20 would take 2 hours. So with a case like this, the faster you go, the shorter your time is going to be. The slower you go, the more your time is going to be. So that's how an inverse relationship works. So once again, I'm going to show you how to set up the proportion. We'll give you the formula. So our proportion is used with inverse variation. So we set up our two exact, formulas that we had before. We've got y1 equals k divided by x1, and y2 equals k divided by x2. So just like we did with those previous examples, we're going to get x by itself. So the way we do that is by multiplying both sides by x1. Okay, so if we multiply both sides, by x1, we get k by itself. Sorry, that started as an equal, should be an x. So multiply both sides by x1. Here we're going to multiply both sides by x2. So same logic as the previous two, because they're both equal to k, we can set them equal to each other. And that is the formula that you used for inverse variation. So let's look at an example for that. Okay, so our inverse variation, just want to copy that formula so it's on the screen again. We can use that. Okay, so if r varies inversely as t, so this time we're using r and t instead of x and y. So r equals 6, -6, that would be your r1. T equals 2, that would be your t1. find R when t equals -7. So we can set that up. So R1 times T1 is -6 times +2 equals, and then we don't know R2 times T2. Okay, so simplify up. So this simplifies to a -12 equals, and this is a -7 times R2. So of course, in order to get that R2 by itself, we would divide both sides by -7. So these will cancel. And now R2, we reduce down those negatives. They cancel each other out. You can leave it as 12/7. You can do a decimal reduced fraction, whatever you're feeling. All right, we are going to skip over this problem and just stick to the basics. I'm sure you're okay with that. Our last one is combined variation. All right, so combined variation, that occurs when you've got some sort of combination of direct variation and inverse variation. Okay, so we could say something like y varies, and maybe we want it to vary directly as x, but inversely as z. If, and then we'd say y equals, so you've got k times x and then divided by z. So the direct variation puts x up here. The inverse variation puts z down here. So that would be our formula. I don't have an exact formula to give you as an example, but the example that I want to use for you for combined variation, let's say this is the number of minutes that it takes to solve a set of math problems. Okay, so number of minutes to solve a set of math problems. It varies directly as the number of problems, meaning more problems, more time, and it varies inversely as the number of people that are working on it. The more people that are working on it, the less time it will take. So more problems, more time, more people, less time. So you've got direct and then inverse kind of combined into one scenario. So our last proportion, our last example here will look like this. You've got your first setup, and your second setup. So here's what we're going to do in order to get k by itself is we're going to multiply by the reciprocal of this thing. So you're multiplying by z1 over x1, top and bottom. Okay, so we multiplied by z1 over x1 and then got k by itself. And we're doing the same thing over here. Multiply by the reciprocal. Multiply by z2 over x2 to get these to cancel. Do the same thing over here, multiply by z2 over x2, and then we get k by itself. Same logic, fourth time. If they're both equal to k, they must be equal to each other. So this is our equation that you're going to be using anytime you have combined variation. So for our last example, we'll just be able to pull right from these numbers. This time we're using f, g, and h. So it varies directly as g and inversely as h. So you'd be using like f times g over h for all of these examples. So find g. Remember, whenever they tell you to find, that's your second set of points. We've got f equals 6, h equals 2. If, and then when they say if, this is the points they're offering you. These are the original set of points. Okay, so we're going to set everything up. So we've got find g when, and then here's our original. So g equals 18, that's going in as y. So 18 times g is going, or I'm sorry, this would be f, and this would be g. Those would kind of be swapped. But still, g times f, and then divided by the value of h, equals, we don't know g. We know the second value of f is 6, and then we know this value of h is -5. So directly as g means the g goes in the numerator. Inversely as h means the h goes in the denominator. So we're just going to simplify all this up. So 18 over 3 reduces down to 6 over 1. So this is now 30 equals, and then g2 times 6 over -5. So a quick way to get the g2 by itself is to multiply by the reciprocal. So you can get both of these to cancel right away. So we're going to multiply this by the reciprocal. So to simplify this down, the 30 over 6 reduces down to 5 over 1. And so g2, if I multiply this out, -5 times 5 gives me a -25, and that is my final answer. So make sure you guys are keeping these formulas with you while you're working. It'll take you a couple tries to get them all memorized.